digitsum. We're going to write digitsum recursively. Here's the answer, but before we do the answer, let's go over here and let's write it. So we have this function digitsum, and when we call it with a number, we want to return the sum of the digits. And let's start with something simpler, like digitsum of the number 12 should equal 1 plus 2. Fine. We define a function, digitsum. It takes an integer n, and it's going to return the sum of the digits in n. When you think recursively, the goal is to assume that you have the problem solved for a smaller version of the problem. So let's actually do that so this makes sense. So here, I can say that the sum of the digit sum, let's say that n was, just for fun, if n was this number, I'd say the digit sum of that number is the first digit plus the digit sum of this number. So this number is smaller, it's everything but the first digit. And because it's smaller, we would recursively say, well, what's the digit sum of that number? Well, it'd be the first plus the digit sum of that number. And it keeps getting smaller. So the smaller case here is dividing n by 10. Take the digit sum of that recursively and add into it n mod 10, the ones digit. So the ones digit plus the sum of all the other digits. And maybe this would look better if we did it this way, perhaps. Not that it really matters, but we'll do it this way. So the ones digit plus the sum of the rest. And that's what you want to return. Okay? And this looks good. We'll go ahead and run it, and it doesn't work. Maximum recursion depth exceeded. So what happened was, it said, all right, digit sum of 1, 2, 3, that's 3 plus the digit sum of 1, 2, or 12. Well, digit sum of 12, that's 2 plus the digit sum of 1. Digit sum, when n is 1, digit sum of 1 is 1 plus the digit sum of 0. Well, it keeps going. The digit sum of 0 is 0 plus the digit sum of 0. And now we see the problem. It's going to keep going forever, calling itself. And this is in general a problem with recursion. With recursion, since you solve the problem by calling itself, you will call yourself forever, which is known as infinite recursion. It doesn't run forever like an infinite loop because every time that a function calls itself, Python has to remember all the new local variables for that new call. These are stored in what's called the stack. And there's only so much room for that stack. And therefore, if you have infinite recursion, you actually crash with a maximum recursion depth exceeded. In any case, what you want to do is say if we're in some base case, return some non-recursive result. Otherwise, we're in a recursive case, we'll go ahead and return the recursive case, which is here. So you have to think about what is a case where I don't need recursion. And in this case, it would be if n is 0. If n is 0, well, what's the digit sum of n? It's just 0. So when I do 1, 2, 3, that's going to be 3. That's going to be when we call digit sum of 1, 2, 3. That calls that says 3 plus digit sum of 1, 2. Well, digit sum of 1, 2 is going to call 2 plus digit sum of 1. And digit sum of 1 is going to say that's 1 plus digit sum of 0. But finally, digit sum of 0 is a base case. And it just returns 0. No recursion. Well, that becomes 0. 1 plus 0 is 1. So digit sum of 1 returns 1. That now becomes 1 plus 2. Digit sum of 1, 2 becomes 3. And digit sum of 1, 2, 3 returns 6. So when we run this, the first one works, second one fails. There you go. Maximum recursion depth exceeded, but did we get past the first one? Let's find out. Let's actually just comment out the second one. We run, it works, print, wahoo. So we see, oops, gotta probably have the same quote there. And we see wahoo, there's our wahoo. So this works for 1, 2, 3, but it fails on the negative number. And the reason it fails on the negative number is, well, let's see. When we're negative, it's n mod 10 plus the digit sum of n divided by 10. Well, this logic right here certainly was not designed with negative numbers in mind. And we can certainly say like this and set n off to be the positive if it's negative. The other thing you can do is you can say if n is less than 0, you can go ahead and return that. You'll do it recursively, the digit sum of negative n. You can do it that way as well, which is in fact the way in the notes. So digit sum solved recursively. Most of this is not what I consider the recursive thinking. The recursive thinking is right inside here. That's really the core of the solution. Then you have to add your base case, and then maybe a special case, in this case for negative numbers. That's digit sum.